Vitaly, thank you very much for being here with us. You flew from Porto in the morning and you're flying back to Porto this evening. And after that, you're flying back to Lisbon for Web Summit,
yes.
right?
Yes,
Thank you.
Flying. All right. All right, so I think I'll need the clicker, and if you can get the presentation up. So good afternoon, everybody. Just to have an idea of who's in the room, how many are undergrad students? Okay. How many are grad students? Anything beyond that? Okay, just entrepreneurs? Okay, how many of you have started a company before? Okay. Mentors don't count. How many are you planning? How many of you are planning to start a company soon? Okay, all right. So hopefully I will give you a little bit of an idea of where you should be working, what areas. So I'm sure most of you are too young to remember this movie, Bill and Ted's Excellent Adventure, but it's Keanu Reeves' first movie. So before Bill and Ted, there was Bill and Dave, Hewlett & Packard. So HP is Silicon Valley's first startup. 1939, first round of investment was $538. First customer was Disney. So my job now, since joining HP in March, is to find kind of our fourth iteration of HP. And today the company actually split about a year ago into two, and we're the little brother, HP Inc. We only have 50,000 employees. We'll do about 55 billion revenue in the next year, and we sell into 178 countries through 250,000 channel partners. And we are in three businesses. So we're in printing, in 3D printing, and I'll tell you much more about that, and in personal computers. So we lead the world in personal computers, both in commercial and consumer, same thing in the 2D printing world. So we'll see what happens in 3D. So, but I'm not here to give you an HP commercial. I'm here to talk about you and the founders in the room, or the future founders in the room. So normal career path that all your parents are going to tell you, and the reason you went to college probably, is so you can get good grades, get into a good college like this, then get into a good company with your good degree, and get regular promotions, then one day retire, play golf, and die. Right? So that's the American dream with the golf part. You can insert your hobby, whatever you like to do. So that's a normal career path that has been going on since the Industrial Revolution, let's say. But it's changed a bit, right? Startups are kind of the new sexy thing. And everybody thinks that a startup career path is very easy. You read about these companies that are greatly successful overnight. Reality is the path is much more difficult than you'll see, right? This is a very treacherous, very difficult path. So I'm here to warn you. So as one of my favorite quotes, Ben Horowitz, as a startup CEO, I slept like a baby. I woke up every 2 hours and cried. Right? So this is, I can tell you from a lot of firsthand experience, this is very, very true. Right? So startups take a long time. You might end up looking like Gandalf here one day, working on your startup. So it takes about a year to develop an idea and another year or so to see if anybody cares, if it's a product, if it's something that somebody wants to buy. If you're successful, it's going to take 5 to 8 years of your life to go through this process. So let's do some math. How many of you are about 22 here, right? Or a little bit before 22, right? Okay. So for a lot of you in the room, you'll see that maybe you'll start your first startup right after college, and you will likely fail, right? It'll take you a couple of years to go through it. It'll be painful and not fun in some ways, but you'll learn a lot and you'll fail. You might go back to grad school. You might go work for a big company. You'll be a little bit smarter. On the second one, you'll fail faster, right? Within a year. That's kind of typical path. So on the third one, maybe you've gotten a little bit more experience. Maybe it'll get a lot further. You'll spend 5 years of your life on it. Congratulations, you're in your early 30s. And the next one will take you to your mid-30s, at which point life's other priorities take over, and you're going to spend time with your family. You're going to go get that big corporate job, and your startup time is done for a lot of people. Okay? So this is the reality of it. It takes a lot of time, a lot of non-refundable lifetime. You can always make more money. You can always do a lot of other things, but you'll never get more time, right? So my goal and job, I feel, as a mentor, is to help you get through this journey and improve your odds of success. And to do that, not everything is a mystery. There are a lot of things that You can learn from experience, but you can also learn from others' experience as well. So we'll talk about real quick 3 different things: how, where, and what to work on. Okay? So let's talk about how. So a startup is an experiment in search of a business model. Building a startup is much closer to the scientific method than it is to running a small business. Okay? Think about that for a second. A startup is not a small version of a large company. It is an experiment, okay, at the first stage. So what you're looking for is a business model. You're looking for a business model, you're looking for who your customers are, how to sell to them, all of these things. You're looking to then start building a repeatable sales model, and then you start realizing what business you're in, and you can start building a management system around that, okay? Then you get into probably the most exciting time in your startup life, which is the transition period. This is where you're going from a startup idea to growing up into a real company, right? And what will happen is right around the time you break even or become profitable, you're at about 150 people, you start hiring managers that are experienced and have gray hair, you become a company, okay? This is the path. So the goal is not to be a startup founder forever. The goal is not to keep going to Web Summit every year and tell everybody that you're a startup founder and give out a CEO business card of a 1-person or 2-person company. The goal is for you to figure out the business and graduate and become a company, and then later become an enterprise, a large company that's dominant in the category. This is what we look for. All right, so if we get a little bit academic, and what better place? All right, if we look at CLAYTON Christensen's technology lifecycle S-curve, for a long time, each technology goes through this period of research, right? So we're spending a lot of time and money into a new technology, and we can't build a product on it yet, right? It's too early to invest. This is where large companies, labs are investing time and money. This is where university research comes in. And at a certain point, there's a sweet spot. The technology is ready for the market is ready for the technology. This is when you build your startup, okay? And that window is very short. It's only a few years for each technology. And at a certain point, it becomes mature, right? You probably wouldn't start a new social network today, but it was a very hot idea 10 years ago, right? You probably wouldn't start a new mobile phone company either. There's a lot of things you wouldn't do, and I also would not recommend that you invest the next 5 to 8 years of your life into a dog walking app, right? That's kind of done. We'll come back to that. So what makes startups very special type of new business is that they go through staged financing, right? This is what makes startups a lot different from small businesses. Small businesses, the model is pretty much figured out. You can read a book, you can go buy a book that says, you know, how to open a restaurant, how to open a hotel, how to start a consulting company. You just follow steps 1 through a million, and you got yourself a business. Startups, by definition, you are inventing a new business. You're solving a problem in a new way. You're using new technology to solve an old, boring problem, right? So you have to invent your business. And in that course, you're going to be losing money for a little while, right? And at a certain point, you're going to start making money, go positive, hopefully break even, and then hit escape velocity. I'll tell you a little secret, most companies don't get there. But if you overlay the staged financing of how venture capitalists look at these types of special companies, is if you have a concept, you can raise seed capital. You get your first customers, you can raise Series A. You start understanding what business you're in, you start scaling, you start adding subsequent rounds of financing, on and on and on. And you get to predictable scale, and that's when you go public, right? So this is very academic. This is ideal world. No company goes through the smooth path. Usually, it looks something like this, right? And there's lots of different financing and bridge financing and all sorts of problems you'll have to solve. But this is what a startup is supposed to do, okay? Now, if we look at Silicon Valley since the 1960s, you'll see that there have been a lot of different technology S-curves, and there have been a lot of big companies built on those S-curves, right? So for example, integrated circuits gave us Fairchild, well, first of all, Shockley, then Fairchild, then Intel, National Semiconductor, AMD, these huge names. This is when these companies were born. If you look at personal computing, I mean, HP got into the personal computing business in the early 70s, right? As well as IBM, etc. These companies existed before. And of course, Apple in the mid-70s, Microsoft, and on and on and on. And you can see some of these S-curves that received a lot of money from investors never matured into big businesses, not yet at least. So the question is kind of what's next? And this is the reason that investors are going after buzzwords. Right? You hear all the buzzwords now, AI, VR, drones, all these things. Because that technology has reached a point where we're going to see the next enterprises, the next billion-dollar companies built on this wave, right, in each one of those technologies. So where? We're obviously not in Silicon Valley, right? And it's important to understand what an innovation cluster is, right, and what in each ecosystem needs. So on any given day, there is any number of groups from different governments, from different universities, from all over the world that come to Silicon Valley, and we like to call that the Silicon Valley petting zoo. So they come over, they'll go and take pictures with the Facebook sign, they'll go take pictures in front of the Apple office, Google, etc. They'll go feel the innovation. And everybody's trying to replicate Silicon Valley, which is impossible to do because it was something that was uniquely built over the course of more than 50 years, or 60 years at this point. So an innovation cluster can exist anywhere. Certainly you need entrepreneurs. Certainly you need venture capitalists to invest in those entrepreneurs, but that's not it. You need a lot more than that. You need large companies that are going to invest in R&D in a lot of these new technologies, right? You need them to also be acquirers for a lot of these companies. So most companies don't survive, but the ones that do exit, the small amount that do exit, are companies that are acquired by the larger companies, not the ones that go public, okay? You also need universities, and the role of the universities is to graduate engineers that develop this new technology and that are specialists in certain technology, and they're graduating business students who start doing the sales and marketing part of it. And in Europe in general, Europe is a little bit behind US in sales and marketing knowledge and experience, but engineering is quite strong. Now, here's the secret of Silicon Valley. It's the management layer. So in Silicon Valley, there are about 50,000 director level managers that have scaled companies from idea to exit before, right? They have that experience that you can't get out of a book. And when companies get to a certain scale and they're trying to go from 20 people to 100 people to 1,000 people, there's really only one place in the world that they can get those managers that can help them build that company. People that know how to build a sales team, people know how to market this specific type of product, have the relationships, all those things. So this is something that you cannot replicate, and it's going to take multiple generations of entrepreneurs to come back with that experience and gradually, organically grow the ecosystem. You also need professionals. You need lawyers that understand venture capital and how to structure these deals. So you don't sell 90% of your company for 50,000 euros, right? Anybody have a deal like that they've dealt with? You also need government. So government has a very important role in this world. Government is supposed to create the economic conditions for all of this to work. It's supposed to create the incentives for venture capitalists to invest in these highly, highly risky companies, 80% of whom will fail. And the US government did this. So US government was the first customer of Microwave Valley before it was Silicon Valley. And the Department of Defense was a big, big customer for all these technologies because it was the Cold War and signals intelligence and all these things were very, very important and a big budget item. And I encourage you to read about the history of Silicon Valley. But then the government started bringing East Coast investors who were investing in big companies and big public companies. They were incentivizing them. So venture capital is short for adventure capital because it's so risky. But if you follow the adventure, it could be a lot of fun and it could be lucrative. You'll find the treasure. So all of this lives in large pools of private capital. And this is important. So the private capital, kind of the smart money, right? You'll hear that term if you haven't heard it already, are people that not only can write you a check for your startup, but they can give you advice. They've gone through the experience. And it's really important that in countries like Portugal, which are a relatively small market, it's likely that the companies that become successful and big, the founders will move to the US at some point to scale the company, but it's very important that they come back with their experience, with their money, to invest in the next generation. And the next generation in startup world is about 5 to 10 years. Right, so it goes quick. And then of course the public stock market is the target. Everybody's investing money because they think at some point this company has a chance of exiting. Odds are that it will be bought by a larger company, but you need to have this ability to go liquid, right? So take your stock and turn it back into cash at some point. So clusters of innovation are very important because they also affect competition, right? And this increases productivity of the companies that are in particular industry. It drives the pace and direction of innovation, and it stimulates the formation of new businesses. So in Portugal, for example, Portugal is known for several different industries, right? You have, in Portugal, you have great, leather goods, shoes, Porto wine, etc., and a lot of different things where it's some of the best in the world, right? Because you have a lot of companies working close to each other, and employees go between companies, or they'll get sick of the big company and go start their own, but they're able to work with the best in the world in their industry, right? Same thing goes for technology. So if we look at top 20 startup ecosystems around the world, Silicon Valley is certainly number one, but Tel Aviv recently became number two. And 15 years ago, 16, 17 years ago, thank you, when it was a dot-com days, a dot-com boom, Boston was number two. Now it's number 6. And all of this changes all the time, right? I'm sure most of you know about Estonia. 1.2 million population, because of Skype, is quite a powerhouse. It's outsized in its ability to create great companies, because you have so many people that came out of Skype with that experience. You had hundreds of people in such a small country that went through that company's progression, right, from idea to exit. And if you look at US, right, if you think I'm going to get on a plane, fly to San Francisco, and there's going to be somebody holding a big check for me and invest in my company, first of all, Bay Area, San Francisco, is the Olympic Games of startups. It's the best of the best in the world. So if you're good here, you're going to arrive there, and it's basically like being in a top university. Everybody around you is very smart and very talented, and you might feel a lot of stress and pressure. But the other part of it is that it's not necessarily the right place for your company. It really depends on what you're working on, right? So if you're working on financial technology, fintech, I'd probably recommend you look at London and New York before you look at Silicon Valley. Or if you're looking at games and entertainment, you would look at LA. There are a lot of clusters around US with a lot of traditional businesses like Detroit and automotive. All of these different clusters that formed over many, many years, right? So it's important to kind of look at, if you're looking kind of from the position of a government, let's say Portuguese government, it's important to help innovate from position of power. So what is Portugal good at? Start building a cluster around that. And the next wave, and we'll get to the what in a second, but the next wave of technology is not all software, right? Silicon Valley started specializing in software for the last 20 years, and a lot of the electrical engineers, mechanical engineers, all of those kind of talents and skill sets are not there, right? So you can actually create a company and get pretty far in other places, right? Develop technologies. It can be born anywhere and be successful. So the what, this is the fun part. What should you be working on? So as I mentioned, you probably shouldn't be working on mobile apps anymore. There are 2 million apps in the iOS App Store, and that's pretty much done. So if you're going to launch an app, it's going to cost you a lot of money to get every user to stand out and get the attention. So you really have to think about, where do you look next? What's going to happen next, right? If it's going to take you a couple of years to develop your idea into a product, you really have to think about, where is technology going to be in a couple of years, right? You're shooting a rocket, and you need to land on the moon, and the moon is a moving target, right? So hopefully this will help you understand this a little bit. So we look at 4 specific areas. There are other interesting areas, but we look at 4 particular areas. Together we call it the blended reality experiences, and it's hypermobility, Internet of all things, smart machines, and 3D transformation. All right, so I'll talk about each one here. So today we take for granted, and a lot of you were kind of born with Internet already around you. But now we take for granted that we have high-speed mobile internet, we have devices that collect data, everything goes to the cloud. We consider this hypermobility. Well, very, very soon, hypermobility will mean nanocomputers in your bloodstream, right? This is real. This is coming. I see companies developing this. So all these sensors, everything is going to be inside you and much more real time, right? 5G internet is coming, which is 100 times faster than what we have. Now, Internet of all things, IoT, is quite a buzzword, and it can mean a couple of different things. It can mean little devices that you buy on Kickstarter that connect and collect some kind of data and improve your life and make something more fun and everything else. But the reality is that every single thing is going to be connected to the internet very soon. That means that the chair you're sitting on will have an IP address, right? It'll be collecting some kind of data. It might be collecting how many people showed up to the lecture, and if somebody's doing a guest lecture, I can get in contact with all of you, or vice versa, without exchanging business cards. All of this is coming. And this gives you a huge opportunity to do things up and down the technology stack. That means security, distribution, the devices, all of these things are going to change, and there are going to be a lot of new opportunities for you to look at as far as creating devices. So this is a good example. It's an internet-connected beer package that will reorder itself when you take the last beer. It's very important, right? Convenience. So smart machines, this is basically robotics. So first generation of robotics, we're talking about hydraulic muscles, machines that can replace the physical labor. Now we're talking about smart machines that can make decisions, right? They can make decisions in certain specialized areas, and later will be generalized. So if we look at kind of where artificial intelligence is at this point, all of you know Breakout. It's a classic game. It's a brick wall. You have a little slider and a ball, and you hit it, and it breaks the bricks, right? So a good human player can go through a level very quickly. Some researchers gave an algorithm the ability to play this game and teach itself. So this is called machine learning. And at first, it wasn't very good. But within about 40 minutes or so, it was able to solve the whole level with one hit. It figured out exactly where it needs to hit the ball to beat the entire game, right? This is much better than a human. And this is kind of an experiment, but it's really important now we can apply the same type of technology to more important puzzles. So this is a flat worm, right? This is a worm that's that's kind of a disgusting little animal, but it has a very special power. It can regenerate itself, right? So if you cut it in half, it's going to grow the tail again. And scientists could not figure out for over 40 years, they're trying to solve, how does this happen? How does this work? Well, they put an algorithm to work, and within 2 days, it figured out, solved this puzzle that humans couldn't, period, right? And where is this leading us? This is leading us to much more complex systems, like these robots. So Pepper the robot launched last year, about a year ago, in Japan, sold out in a few minutes, and the special power with this robot is it can read emotions and it could show emotions, right? So this is much more beyond hydraulic machine that lifts a big heavy part in the factory. This is a companion that could be a companion to your grandmother, right? And in Japan, the average age is already over 60, right? This is very important for that type of culture, that type of society. Now, the last area, which is arguably the most exciting, and I'm a little biased because we're in this business, is 3D transformation. So before Industrial Revolution, everything was done by hand, right? And it was very labor intensive. Industrial Revolution, which took about 80 years, gave us blueprint design and mass production. Internet gave us just-in-time computer-aided design and just-in-time machine production, and here's approximately where we are right now. So what's coming next is we're talking about completely digital design, completely digital production, right? Nothing, there's no intermediate step. And then ultimately, we're talking about complete democratization of production and manufacturing. We're talking about a magic pipe coming into your house at some point. Next to your electricity and water, you'll have magic dust, and anything you order online will be created for you at your house instantly. So we're talking about no more logistics, no more distribution, no more manufacturing. Everything will be done just in place. And you may think that that's crazy, that's Star Trek, but in about 10 or 20 years, you'll see. You'll remember this. So in May of this year, we announced our first 3D printers, and these are commercial grade 3D printers. So these are state-of-the-art commercial 3D printers that are now cost competitive and fast enough for small batch manufacturing. In a few generations, they'll be cost competitive to replace conventional manufacturing, injection molding, and other technologies, right? What is this going to mean? It's going to mean that not everything will be made in China anymore. You'll have factories in different countries that are manufacturing goods for that country just in time, just in place, and fully automated, right? Now, what's really interesting is that the way these machines work is it's a concept of a voxel. It's a volumetric pixel. So it's 21 microns at this point, which is about 4 human hairs. And what we can already do is already affect this voxel by voxel with certain types of agents to change the color, to change the transparency very soon, to change the conductivity, right? So what I'm getting to is that we can very soon print complete devices. Now, it's not just a model of something, a crude model, but it's a complete device with batteries, with optics, with all these things. So I'm going to show you a quick video. So hopefully sound will work on how we approach this.
To you, designers and engineers, captains of industry, and leaders of thought, anyone whose ambitions have ever exceeded what was possible, this is your moment. Your rewrite history, the world is not flat moment. Every facet of how you design and manufacture is about to be reinvented, and it all starts here. With the smallest of building blocks, the mighty HP Voxel. You and it are about to change the world by advancing radical prototyping, accelerating manufacturing, and taking precision and strength to unheard of heights. From today forward, the 3D printer is a factory for thought, where the things we make will make us smarter, better, more human. What a future we'll create with new materials and embedded intelligence. Together, we'll bring extraordinary to the everyday and reality to dreams light years away. Welcome to the age of digital production, on demand, a world without waste, without inventory, without warehouses. Meet the first HP Jet Fusion 3D printers, the digital furnaces of the next industrial revolution. Join us as we engineer the never-before voxel by voxel. HP Multi-Jet Fusion. Keep reinventing.
So hopefully HP is a little sexier now, right? It's a little more interesting. My job is complete. So what does this mean for us? What does this mean very, very soon is that we'll be able to print complete devices and pretty complex ones. We'll be able to print complete, electronics, chips, all these things on demand. We're going to be able to do bioprinting. So the combination of a nanobot in your bloodstream will be able to, you wake up and it says, you have a vitamin D deficiency. I printed a pill for you. Here, take this and you'll feel better, right? We're talking about those kind of things. We're talking about, bioprinting of food. Maybe just as good as the cafeteria food you have here. So, that's a local joke. So, we're also talking about something that hasn't been possible yet, which is 4D, a little bit, we call 4D printing. MIT actually is doing research on this, which is smart materials. So that means that an airplane wing might be printed, right? And it will have a material that will react to the air pressure, right? So these are kind of self-assembling materials that react to certain situations. There's a lot of research in that area. And if I blow your mind a little bit further, haptic holography is an interesting area, and maybe this will take many, many years from now, but we're talking about interacting physically with virtual objects. So right now, if you do a little bit of search for this, you'll find that there are already companies working on this for VR, where you wear a glove, and as you touch an object, it will pull your fingers back and you feel like you're touching an object. But at some point, we'll be able to control this virtually and control our neural pathways and be able to interact with virtual objects. So maybe you'll be sitting on virtual furniture in a virtual classroom, 20, 30, 50 years from now, right? So this is kind of where we're headed. And my big point is this, is that you need to plan for what you're going to be working on, where you're going to spend your non-refundable lifetime. And as hopefully our future president says, we're very nervous, actually, I'll tell you. Very, very nervous. If you fail to plan, you plan to fail. So think about where you're going to invest your career, your life, your talents, what technology you need to learn, and what your dreams are, and dream a little bit bigger, dream into the future. Don't think of today as your context. Think about where the world is headed, right? This is the Silicon Valley mindset. You walk around and you look for problems to solve, right? That's really what it is. Silicon Valley is not a place, it's a mindset. So with that, thank you very much. If you want the slides, you can go to this URL, put in your email, get the slides. You'll also get the first chapter of my book that's coming out in January, which is a little bit of an accelerator in a book. So with that, thank you. I don't know if we have time for questions, but okay. Thank you.
Well, first of all, thank you very much.
So now it takes about 20 seconds to come up with a question. We'll give you a second to do that.
I'll come up with the first one, Vitaly. So this first fusion printer, was it designed in-house or was it out of a venture that you invested in?
So our venture group just started in May of this year. I joined the company in March. The 3D printing business unit was put together a couple of years ago. And it's actually, most of the team is actually in Barcelona. So Barcelona and Washington State in the US. It actually comes out of a lot of our 2D printing technology. So we have what's called a page wide, so you can print basically an inkjet that doesn't have a head anymore, but it's one big head, and it sprays at the same time, and the page comes out really fast. So we're doing something very similar, where the dust is spread layer by layer, and then this curing agent is sprayed at very fast speed across the whole bed. So it's actually very similar. Think of it as 2D printing layer by layer. And there's some really cool other technologies out there like carbon 3D that use light to print even faster. So it's a really exciting space.
Magnus?
Thank you for a very interesting presentation. I was curious about which of, because you did define different niches for the application of the 3D printing this way. Where would you see that the lowest hanging fruit for you will be? Where will it take off fastest?
I can't claim to be a 3D printing expert, not even close. I'm very lucky to where we are part of the CTO office of HP, and we have people in HP labs that are material science PhDs and everything else. So when I see an interesting company that has a great team, I have a great resource where I can give it to my nerds, and they can tell me if this is an interesting technology or not. But I can say this, that there are a few different technologies that are used for 3D printing itself. So SLS is one, we're kind of close to that. Carbon does something entirely different, and a few other ways. And we're looking at all of them. We're looking also at metals and ceramics and other things beyond polymers, beyond plastics. But we're also looking at all of the software that enables this. So for example, we have a really interesting computer that's called a Sprout, and it's a touch computer, but it also has a projector and a 3D scanner camera right in front of it. So you can interact with it in a completely different way. So as you're entering new design paradigms and you're designing new kind of seamless ways and parts and things and kind of a new paradigm of creativity, we're talking about kind of this on-ramp, the creative tools to be able to create these new products in a better way, right? You wouldn't create something in 3D in Photoshop, right? You would do it in some kind of a CAD, but there are more convenient ways that are specialized for this. And the other part of it is, that's really interesting, is that we're going to need to protect this data's intellectual property, right? If somebody gets a hold of your design, they basically have your product, right? So just like, you know, book authors and musicians kind of went through this digitalization of that craft, right? And it had certain problems with piracy and all of those things. We're talking about now that you'll be able to pirate a very complicated device in a few years and print it out at home, right? Those kind of things that we're kind of looking out for. So a lot of really interesting things in this area that we look at.
Hello, Vitaly. Very nice presentation. Thank you very much. I would just like to understand what's the position of HP, I don't know, compared to 3D systems and others. So are you positioning yourself into the industrial part, into the consumer,
Definitely
metallic, polymers? Where actually do you feel, or do you think that it's your sweet spot?
So right now, industrial is the sweet spot, I think, for most companies. There's really, technology is not far enough along to be applicable to consumers. And that's actually a big problem that happened with 3D printing in general. There's a lot of hype a few years ago about 3D printing, and it was a little bit misguided, because how many iPhone cases could you possibly need, right? So there's really no reason for most people to buy a little home 3D printer, because it's just for tinkering. And everybody got disillusioned, right? It's a normal process, right? It's called the trough of disillusionment. And everybody says, oh, 3D printing, that's just buzzwords, it's stupid. But in reality, the application now is commercial, right? And for the next few years and next few generations of the technology, it's going to be eating into small batch manufacturing, then medium, then large scale manufacturing. And at a certain point, the technology will be mature enough to be brought back into the house where the consumers will want to, it'll be like an appliance. You'll be able to print whatever you need, whatever you want. Order a pair of shoes on Amazon or equivalent Amazon of the future, and you print them out, right? We actually already have Adidas as a customer, and they're doing prototyping, right? They can print an entire shoe and test the different designs. So, and we're looking right now at polymers, but we're very interested, and there are a lot of new interesting ideas out there in metals and ceramics. It's just a little bit further behind. It's not quite production ready.
Hello, so thank you for the very nice presentation. As you are in a business school, I wonder what sort of recommendations would you have to our students, they're all business here, given this future, what sort of competences would you say that are absolutely important for them to focus on?
So my recommendation, you know, if you graduate with an MBA, you divide the world into 4 quadrants, right, when you come out. I don't have a business school education. I have the business school education of running 3 of my own companies. And that was tough enough, I can tell you for sure. My recommendation, and you're going to see a lot of top universities, including Stanford already, providing you an ability to learn by doing, right? So for example, there's Stanford StartX Accelerator, which is becoming really, really successful with a lot of companies, where you have academic education. You know, in typical business school, you're studying cases. These cases might be 10, 20, 50 years old, and you're learning kind of about classical things. And you're learning what to do. But only by experience can you learn what not to do. And it's 1,000 things not to do that will kill your company, right? So my recommendation is get some hands-on experience very, very quickly and as much as you can, alongside your education, your formal education. I'm a big proponent of formal education because you need the theory as well. You need that basis. But the experience, you know, if you're choosing, you know, if there's a fork in the road, and your question might be, okay, do I go get a boring government job? Do I go to a big company and kind of work my way up, retire, play golf, and die? Or do I go, you know, towards the siren, the Medusa siren of the startup world, and choose this really hard path? My recommendation is that your first startup should not be your own. You should try to go work for a fast-growing startup that's already in that middle period, in that transition period, where you can learn more in a year than you learn in 10 years trying to do it on your own. And with that experience, you can bring it back and start your own company. And that's kind of the path that I followed, is that I went through a startup that in a year went from, I was, I think, employee number 19 or 20, and we got to about 120. And then too bad that was 2001, when the whole world in Silicon Valley ended. But I learned probably half of what I know today is from that experience. Kind of hands-on, and it's been reinforced again and again and again as I started and ran 3 of my own companies after that.
Well, thank you very much. Oh, there's one more. Lisa?
One more question.
2 more.
Hi, and thank you for the presentation. I just wanted to know, you referred to your 3 companies. What kind of companies are they?
Sure. So I was, my talent, I guess, my calling early on was design. And by the time I was 15, I was the youngest employee of Kinko's, which is now FedEx Office. It used to be kind of small print shops and design houses. So I started there early. I ran a design team in a .com. After that, I ran a printing company, commercial printing and design company for 5 years. Sold it. Started a design firm, grew to 3 offices and sold that. And then started a real product company, a real startup, software as a service, also in the graphic arts space. It was an e-commerce platform. And through that, actually, I got to know HP. And that's how I ended up at HP as well. I think there was one last question here.
There was.
Thank you, first of all, for your presentation. You talked about technology and how our world will be tomorrow. And I was thinking about how society will react to all of these changes, and you talked about piracy, and in 10, 20 years, people will be able to pirate objects. And imagine if in 10 years, everybody that has a 3D printer can print a gun. How is the world going to be like if that's a possibility? I don't know. I don't think I want to live in a place where everybody that has a PC and a 3D printer will download it.
So I'll make you feel okay on that side. So just because you can doesn't mean you will, right? So Portugal just made all drugs legal, right? And it doesn't mean that everybody is on heroin outside, right? No. It doesn't mean that people will. This is more of like a socioeconomic type of question. And it can't possibly be worse than the gun problem in the US right now, because you don't need to 3D print a gun, you can just go buy one, right? Too easily. But the one thing that does worry me is actually the fact that artificial intelligence is going to start eating into a lot of jobs, right? And those that are not college educated, that are not using their brain for work, are at a big risk, and really in the next 5 years or so already. So, for example, the most popular single profession in the US, does anybody know what it is? Anybody guess? Probably won't guess. It's truck drivers. There are 3 million truck drivers in the US. There are about 5 million people that support them. Little restaurants along the way, gas stations, all these things along the routes. In 5 years, there will be 0 million truck drivers in the US, right? So the agricultural revolution took 240 years, many generations, 10 generations. The industrial revolution took 3 generations, about 80 years. We're going to go through a order of magnitude bigger transformation in the next 10, 20 years within the course of 1 generation. And a lot of people will not have the opportunity or the ability to retrain. You're not going to retrain truck drivers that didn't finish high school to be computer programmers, right? So this is actually what keeps me up at night. And it's a little bit scary, and you can already see this effect. Brexit, Trump, all these things, even ISIS, it's the same effect. You have the haves and the have-nots. And there are a lot of have-nots, and there are going to be more of the have-nots than the haves, and they're going to be pissed off because they're not happy with their position in the world, and for them, life is worse. So, you know, this slogan that Trump has, which is "Make America Great Again," couldn't be further from the truth, because if you look at all the statistics, America is much better than it was 8 years ago, economically speaking, but not for a lot of people that feel like they fell out of society, right? And at first it was manufacturing moving to China, but from China, manufacturing is just going to get automated. So I was in Shenzhen just in April, went into a big manufacturing plant. On the first floor, you see a lot of yellow coats, hand assembling everything. You go to we got a tour of the next level, and it's a completely robotic line. It's just managers looking over a few machines. So this is the big problem, and the answer might be something that has to do with basic income, right? Our economic systems, our political systems are going to have to change drastically to keep up with technology kind of eating into the way we work, the way we earn a living, and our economy is going to change drastically. So you can go, so everybody knows TechCrunch, yes? So I'm a contributor to TechCrunch. I actually wrote an article on this a little while back, and if you do a search for it, it's called Trump, Brexit, and ISIS are the symptoms, technology is the problem. So that's my kind of extended thoughts on that. So, but it's a little scary, yeah, admittedly.
Thank you very much, Vitaly, for this inspiring talk. It's great to have you again in Portugal. Thank you. Hope to see you next week again. Thanks for coming.